This is number 1 on the 2025 AP Precalculus exam, the free response question part of the exam. This is a calculator required question, okay? So it gives that some function f is decreasing and is defined for all real numbers. And then they give selected values of the function at these values of x, okay? And g is given by this polynomial here, okay? So part A, they say that h of x is g composed of f of x, which is g of f of x. They give this. Find h of 1 as a decimal approximation or indicate that it is not defined, okay? So h of 1 is, I usually like this notation, g of f of 1, okay? So what's f of 1? That is 1.75. So we need g of 1.75. G is this. I would put this as your y1 in your calculator and then go back into this in the graph, define the functions of the graph, that mode, and then go back into the normal calculation mode, and do y1 of 1.75. Then you would get 0.3334, something like that, if I remember correctly. So just keep 3 decimal places is my recommendation, okay? And then next part, they say find f inverse, maybe let's write that a little better, f inverse of 3.5 will indicate it is not defined, okay? So I saw that some instructors who already solved these, I know I'm late to the game, did not give a justification whether f inverse exists or not. The scoring guidelines aren't out. I don't know if the AP graders will require you to give a justification, but I did over here. Since it's given that f is decreasing, okay? Here's the important part, it's 1 to 1. Since it's 1 to 1, f inverse exists. This is the key. Even if you're not required to write this, this is conceptually the important part. Since it's decreasing, okay, and monotonically decreasing, it didn't say monotonic, but it's decreasing, okay, it's given. That means that since it's always decreasing, the y value is never the same, okay? And if that's the case, that means it's 1 to 1. Okay, remember for inverse to exist, we do the horizontal line test. Remember that guy? That means if there are multiple of the same y values, the inverse doesn't exist because the y's become the x, okay? I have videos about understanding inverses and the concept of inverses and all that, so you can, and shorts on this, so you can go check this out. But again, the important part is, since it's 1 to 1, f inverse exists. Again, I don't know if this is required to write, but I honestly would require it if I were the scorer. But this is conceptually why this is important, okay? Since f inverse exists, f inverse of 3.5, that means what value of x gives us a y value of f of 3.5? That's 0. So remember, f and f inverse, the input and output are swapped. So if we're interested in f inverse of 3.5, this is the input to f inverse. That means we want to look at the output of f, the output of f. Here's 3.5. So we look in the input of f, which becomes the output of f inverse, 0. Okay? You can see clearly the input and output are swapped. Input, output, input, output. Okay, that's an important idea for inverses. All right, part B, find all values of x for which g of x is equal to 0, or indicate no such values, okay? So you could just graph it, and then use the calculator to find the roots, and these are the 3, okay? I also wrote, I don't think it's needed, but I wrote this to explain that since this is a cubic, the biggest degree is 3, okay? This is a polynomial of degree 3, biggest degree is 3, okay? There's at most 3 real zeros. Remember all those rules about how many zeros there are, real zeros and complex zeros, and all those weird rules that they make you learn that honestly I don't think are important at all in the real world. Okay, so since it's cubic, that means there's at most 3 real zeros. So we should keep that in mind when we're looking for the zeros in the graph of this, okay? There might not be 3, because it could be like 3 real, or it could be 1 real, 2 complex, okay? I believe those are the only possibilities, because you have to have an even number of complex roots. They come in conjugates, if you remember, okay? So don't be surprised. In this case, they were 3 real, okay? But in general, don't be surprised at this 1 because it could be this too complex. You just won't be able to see it on the real axis, okay? So here they are. Now, part 2, determine the end behavior g as x increases without bound expressed using a limit, okay? So as x increases without bound, that means as x approaches infinity. So limit is end behavior. Limit as x approaches infinity, and limit's not end behavior, sorry. Limit as x approaches infinity is end behavior, okay? Of g of x is, you technically have the graph, so in the calculus, so you can look there, you'll see that's minus infinity, or we can think of it like this. As x keeps getting bigger, we can ignore the lower degree terms because imagine a million cubed is so much bigger than a million squared, right? And a million cubed is for sure much bigger than minus 1.834. So as x keeps getting bigger and bigger, these two become insignificant, okay? Infinity is so imagine some big number cubed is positive, but we have this negative here. So it'll be negative infinity. Okay? Part C, based on the table, which of the following function types best models f? It's exponential. How do I know that? Well, first of all, it's probably not a quadratic because quadratic, it changes direction, right? Not direction, sorry. It's not monotonic is what I'm trying to say. It increases then decreases or decreases, increases, or increases, decreases. The parabola, okay? Like y equals x squared. Hey, it says it's monotonically decreasing. So most likely it's not a good idea to model f with a parabola. If you're only given this portion, then maybe you can model it with a parabola, but since we're given that f is decreasing everywhere, then we can rule it out quite safely, okay? It's not linear because this is a constant step of 1 in the x, right? The change in y for a linear function should be the same for the same change in x, okay? This is a change of 7. This is a change of 3.5, so even smaller. This is a change of 1.75, even smaller, okay? Logarithmic and exponent are left, okay? For exponential is the better case because you can hopefully see that, well, to get from here to here, you just divide by 2. Here to here is divide by 2. Here to here is divide by 2. So that's times half. So you can model as half to the x times something in front, or plus something also as well. But the parent function is half to the x, or 2 to the minus x. You can even think of it as. But for this case, half to the x, okay, not to confuse you. So exponential. Logarithmic is the inverse of exponential. So I mean, you could probably model it, but it's much difficult. And usually for AP exams, the best answer. So exponential is the best answer. And then in part 2, you have to give your reason. And as I just said, for each step of 1 in the x, we are having the y, or multiplying by half. This multiplied by half is key. This is half to some power. You can write half to the x, something like that. Okay? Or maybe don't write that. This should be good enough as well. Okay? All right, that's it for number 1. Hopefully this was helpful. Please give this video a like if it has helped you in any way. And hopefully I'll see you in another video on this channel.